Hi, this is another video for Math 215. This one will be for Lab 6, least squares 1. And I'll just be explaining little things that trip people up, just like little common details that will help you with your lab. So starting off with problem 1, I'm just creating these NumPy arrays. A couple things that people get messed up on is your X. You'll want to format it as np.array, but what they mean is to have the first row be that 1, 5. That second row be that 1, 10, so on and so forth. Don't do the opposite where you have like 1, 1, 1, 1, 1, 5, 10, 20, 15. Have it formatted like this. And so it'll be two-dimensional. And then your Y will just be a regular array of one dimension. NP array as well, right there. And the reason we have the 1, really quick, is in relation to the equation that you solve for, this V equals V naught plus AT. The 1 deals with the fact that our variable, or independent variable in this instance, is the t, or x here. And if you notice, on the right side of the plus sign, we have 1t, i.e. that 5, 10, 15. But on this side, we don't have a t, and so we won't want to multiply it by any version of t, so we'll just multiply it by 1. And that will be helpful in later problems. So that's problem 1. Problem 2 is pretty similar as well. Just remember that when you're multiplying matrices, use the np.matmul method. If you're multiplying a and b together, you'll want to do matmul a comma b. For problem 3, part 1 is pretty similar to what we did like a couple labs ago, where if you just have ax equals b and you want to find x, then the way to solve that with matrices would be np.linalg.solve a parenthesis b. And so that's where you put your matrices to solve for that x, or in this case, that beta. So that's problem 1. Problem 2, for the mx plus b. So they want us to write a line of best fit for this equation. So it'll just be linear, so it'll be the format y equals mx plus b. Now if we refer to our other equation that we had v equals v naught, and I'm actually going to rewrite this a little bit, at plus v naught. And in our beta, we know that our v naught is beta at 0, and our a is our beta at 1. And this will be t. So when they ask us to create a line of best fit given some x and create a function that accepts some x, they want us to do something like we want to return the y value that we get from here. So in other words, v. And we can say v equals this beta 1, and then the t here that they give us will be the x that is given, or the t that they want us to use is the x that they give us through the function header. So return beta, you can't see that. Return beta 1 times x plus beta at 0. So that way you have this line where you have your slope, your x, and your y-intercept, and you're going to return the y. So that's problem 2. And then, part 2 of problem 3. Part 3 of problem 3 is a tricky one where you have to deal with different plots. The way that I would go about this is inside your, I think it's create plots function, your create plots 1. I would first create an x. And what this x is just a sample set of coordinates. And these are just be the x coordinates. I want to do the coordinates 5, 10, 15, 20 like we had before. And using list comprehension, the way that I'll do that, for reference on list comprehension, go back to lab 2, and that should be a helpful reminder of what you need. I'll do 5 times I for I in range 1 through 11. Oh, 1 through 11. So this will create the list 5 times 1, 5, 5 times 2, 10, all the way up to 50, because it won't include that last 11. So if that's your x, then you're going to have two different y's. Your first y1 will be the line. And you can actually just write that as, oh, and my mistake, you'll want to change that to x equals np dot array. That's very important of all of that. So to get your first y, you'll just want to plug it into the line equation. And you can do that if it's an NP array like that. And they also want you to plot it along with the points that you're given in table 1, I'm pretty sure. Yep, table 1, velocity of an accelerating satellite. And so I would just write y2. I'm pretty sure you can just write it as your y1 that you solve for in problem 1. And then lastly, to see these, you'll want to do plt.plot x, y1. And so this will make the line. And then to get your set of points, rather than doing plot, we'll actually want to say plt.scatter. So this will create a line, this will create a scatter plot. So this whole thing will create the line of best fit and the points that you calculated to get that line of best fit. So that's problem 3, part 3. And then for problem 4, remember that the t that they give us is in essence our x for that equation. And so you'll just want to say like ls1 line and then whatever time they give you. And that's what you'll save as your pred 1. Now going on to problem 4, 5, and 6 are very similar to 1, 2, and 3. You're just going to use a little bit of different variables. And so I think the biggest first thing is when defining our x2, rather than saying like 1, 5, 1, 10, the reason why we say, and the reason why it's defined as 5, 25, 10, 100, and so on, is because if you refer back to our equation that we're using, d equals v naught t plus a t squared, we have this t here on the left side of our plus sign, which is going to be our 5, 10, 15, so on, and our t squared, which will be each of those squared, so 25, 100. And so that's where we get that x array or matrix for. And then the y2 will just be the data that they give you. Beta, you'll solve the same exact way, using your normal coef and normal vect 2s. And then for problem 6, really quick, they mentioned this in the PDF, but it actually isn't too important. They say to remember a equals a over 2. And so most people want to change some a to a over 2 in their code, but the thing is we're always using this a. We're never referencing this a, and so you actually never need to say a equals a2. You can just always use this one. And so I wouldn't worry about that as much as they think you need to. And so when you're doing your ls2 par, remember that now we're using y equals, I have to think about how to write this, bx plus mx squared to a fault. Where your b in this instance is going to be, let me just check to make sure I'm not throwing you astray. Yeah, your b is going to be your beta at 0, and your m will be your beta at 1. And so to remember to use this x and x squared here, and then obviously return your y. That should help with that one. And then lastly, and then again, same thing for plotting, very, very similar to problems 1, 2, and 3. Okay, the last one is problem 7, and like we mentioned before, now we have this equation where we have ln of r equals ln of c plus a ln of t, where this is our m and this is our b. So if you notice that there's no t on the left-hand side of our plus sign, that means our x will have a column full of 1s. And the t over here is going to be ln of t. So it'd be like ln of 5, ln of 10, ln of 15. And so that's how you would implement your x matrices, by having these 1s and then these ln's. And these aren't actually 5, 10, and 15, but that's just kind of an example from the last data set that we used. So for problem 7, yeah, that's how you'll line up your x. To find your beta, that'll be the same thing as the 2 examples before it. And then for problem 8, the last tricky thing to remember is that you want to calculate your r based on your t that you're given. Now the only thing is that your a right now is going to be your beta at 1, but your beta at 0 is actually ln of c. So you can't say that's beta of 0. The way that I would do that is write out np.exp of beta at 0. Because if you remember from just general math rules, e to the ln of something will just equal that same thing. So doing e to the ln of c will just be your c. So I'd do it like np.exp of c of beta at 0 times t to the beta at 1 equals your r, and you want to return that r. Hopefully that helps clear up the things on this lab. Again, this lab isn't too much more difficult than lab 5. I think it's a good respite a little bit from the things that we had to deal with in lab 5. So I hope this video helps. If you have any questions, you can feel free to contact me at my email. Thanks for watching.